So starting off with just some definition stuff, a polynomial just consists of constants, which are your numbers, and variables, which are your letters, and they're joined together by addition, subtraction, multiplication, division, all that good stuff. So when you put them together with all of those different operations, you then create different terms. You can have a single number or a single variable be a term, or it can be a product of numbers and letters and all that good stuff. So big thing here is standard form. It is always expected that you put an answer in standard form, and they're not going to tell you. They're not going to tell you solve this problem and write your answer in standard form. It's expected that you know to put it in standard form. So what that means is the exponents are written in order from the greatest to the least, and we're going to go through that in our little table down there and practice putting it in standard form. Put your largest exponent first, down to your smallest exponent. A degree is the total of the exponents, so the highest exponent is your degree of that polynomial. And again, we'll go through that in our table too. And then leading coefficient, that's just whatever coefficient is in front of your first term. They ask that one occasionally. So let's take a look at our table here. First one we're starting out with is the polynomial 4. So in standard form, that still would just be the number 4. I only got the one term there. Are there any variables with that? No. Since there's no variables here, this is a degree of 0. No letters, degree of 0. So we refer to this as a constant. So name by degree would be constant. However, how many terms do we have? 1. And we call that a monomial. One term called a monomial. Does that word at least sound familiar, your monomial? Yeah. Oh, good. So our second one here, 9 minus 8x, that's not in standard form. This negative 8x needs to go first, and then your 9 comes afterwards. Anything with a letter is always going to go first before just a number. So negative 8x plus 9. The exponent on our x here is a 1, so that makes it a degree of 1. Yeah. No, because the negative is going to stay with the 8. So that's why it's negative 8. Over here it was a positive 9, but they don't put the plus sign out in front. So that negative sign stays with that number. So as I said, this is a degree of 1, because my exponent on the x is a 1. That's my largest exponent in this problem. Degree of 1 are linears. We've done a lot with linears. We've graphed them. It becomes a straight line. You've solved them. We did systems with them. Lots of things. How many terms do we have here? 2. 1, 2. So our number of terms is 2, which makes it a binomial. Okay. Third one. Which term should be going first? Good, the 7x squared. And then your 5x, the larger exponent goes first, and then the smaller one. So our largest exponent is a 2. So that makes this a degree of 2. When it's a degree of 2, we call it a quadratic. We're going to do a lot more with quadratics going forward. We're going to graph them. We're going to solve them. We're going to find out all different kinds of answers using our quadratics. How many terms do we have? 2. So this is still a binomial. We have our 7x squared, and then we have our 5x, 2 terms. All right, next one. Which one should go first? Our 4x cubed should go first. That's our larger exponent. And then plus our 8x. So what would be our degree here? 3. Good. 3. Largest exponent there is a 3, so that makes it a degree of 3. So a degree of 3 That's a cubic. We don't deal too much with cubics. You just have to be able to know what they look like. How many terms do we have again? Still 2 terms, still a binomial. All right, then our last one. We want this negative 3x to the 4th to go first. That's our largest exponent. And then plus our 2x cubed. And then plus our 4. So our degree this time, the degree of 4. We call that a quartic. How many terms this time? 3. And we call that a trinomial when we got 3 terms. So there are more degrees beyond just our 4, but the only ones we need to know are the degree of 0 is a constant, 1's a linear, 2's a quadratic, 3's cubic, and 4's quartic. Those are the ones we need to know. And as I said, there's other ones, but we don't have to know it this year. And then as far as our terms go, anything beyond 3 terms, they just call it a polynomial. So if it's got 4 terms, it's just a polynomial. 10 terms, they call it just a polynomial. So then down here, identifying the different parts, coefficient goes in front. Base is what has your exponent on it, and then your exponent. So like in our first example, what's our coefficient? 3. Our base would be the x. Our exponent would be the 2. So I want you to take a second and fill in those other 2. Coefficient, base, exponent. All right, so what we're going to do today is we're going to go through and review 2 types of factoring. Our first one is our greatest common factor, which we usually refer to as our GCF. So what that means is you have to find the greatest number and or letter that goes into your terms and then factor that out. So let's take a look at the back, or on the next page, I should say. So what we're going to do first is just practice finding our GCF. So whenever you have numbers and letters, you want to look at them separately. So if we look at our numbers here in example 1, I have 4 and 4. So what's the largest number that goes into 4 and 4? It'll be a 4. They're both 4s. It's the largest number I can take from those. And then I have an X and I have a Y. Can I pull one letter out? No, because they're different. I have X's and Y's. It's not the same thing. So our GCF here is just going to be the 4. Let's take a look at the next one. We have a 2 and a 4. What's the largest number that can go into both 2 and 4? I heard somebody say it, 2. And then don't they both have an X? Yeah. So the way our GCF goes is whatever the lowest exponent is on your X, that's your GCF. So our lowest exponent between those two would be X to the first. So our GCF there would be a 2X. All right, let's try our third one. So 10 and 15, largest number that goes into 10 and 15. 5. Now they both have an X. What's our lowest exponent on our X's there? So X squared. And then this one has a Y, but does the other one? No. So just 5X squared, that would be our GCF there. And then for number 4, we got a 2 and a 3. Is there a number that goes into 2 and 3? 1. Okay. But do they have any of the same letters? No. So our GCF here would be a 1. So when your GCF is just a 1, you don't really do too much with it when it comes to your GCF factoring. So I have written here for you all the steps, but instead of reading through them, I feel it's easier to actually do examples with them. So let's take a look at our first example there. First thing we need to do is actually figure out what our GCF is. So between 12x and 24y, what's the largest number that goes into 12 and 24? 12, good. Do they both have the same letter? Nope. So our GCF here is going to be a 12. So to refresh your memories when we're doing our GCF factoring, I'm going to put 12 because that's my GCF on the outside of one set of parentheses. And then to figure out what goes in the parentheses, I need to divide both my terms up there by my GCF of 12. So when I divide 12x divided by 12, we're going to be left with just an x. Our 12s would cancel. Plus, what's 24 divided by 12? 2. And then we would still have our y there, so 2y. And then that's our GCF factoring there. That's our answer. So you got the GCF on the outside and then one set of parentheses. All right, let's try the next one. Example 2. What would be our GCF? What do they have in common? The b. So I'm going to put the b outside of one set of parentheses. And then we need to go up above and divide both of those things by b. Our b would cancel out, and I'd be left with an x for that first term. Plus what? I heard somebody say at y, your b's would cancel again, and you'd have just a y there. So you'd have b times x plus y. I'm going to give you a second. I want you to figure out what is our GCF going to be for number 3. All right, who thinks they got it? What's our GCF here? Johnny?
1.
No. No. Eddie? X. The only thing all 3 of those terms have is an x, so that is our GCF this time. So I'm going to set up my x, and I'm going to set up my parentheses. So remember, I have to go up here and divide each of my terms by x to figure out what's going to go inside of our parentheses. So we have to think back a little bit. When we divide with our letters, we have to subtract our exponents. Remember, this is an x to the first. So 3 minus 1 makes that turn into an x squared. So then plus 7, and again, 2 minus 1. Bring that down just to 7x. And then what happens to our x's in our last term here? They'd cancel and we'd have a minus 5 there. There's our answer for that one. All right, number 4, we got to figure out our GCF first. This one's going to be a number and a letter. So we got to find the largest number that goes into 6, 24, and 18. What number goes into 6, 24, and 18? 6. And then what's our lowest exponent on our p? 3. So 6p to the third. That's going to be our GCF. I'm going to give you a minute. Let's see if you can figure out what's going to go inside those parentheses by dividing. So let's see here. We should have p to the third plus 4p squared plus 3. Did anybody get that? A couple people. So yeah, so here when we divide it, again, you got to subtract your exponent. So 6 minus 3, that's how I got p to the third, and my 6's canceled there. 24 divided by 6 gave me my 4. 5 minus 3 gave me p squared. Here, those p's canceled. 18 divided by 6 gave me a 3. All right, let's try number 5. So again, got to find our GCF first. Now these ones are always tricky. 14 and 42, you can probably sit there and go, I have no idea what's going to go into both of them. So what I always try doing is seeing, can I do 42 divided by 14? See if you can divide it by the smaller one. And does it work? Yes. So our GCF is going to involve a 14, because 14 goes into 14, and we just found out 14 goes into 42. Do they both have an A? Yep. So a to the first, because that's my smaller of the two exponents. And then b to the what?
Third.
Third. Good. So 14ab to the third, that's our GCF. So let's go and divide. Doesn't completely cancel out, no. 14 divided by 14 gives us 1. So you have to have that placeholder of 1 there. But then, yes, our letters both cancel out, A and B. But you have to have that 1 there, otherwise it completely messes up the problems. So then 42 divided by 14 give us a 3. A squared divided by A, again, subtract your exponents. So I would get a to the first, and then b to the what? First again. Always keep in mind when you're doing GCF factoring, if you start out with 2 terms, there's always 2 terms in the parentheses. If you start out with 3 terms, there's always 3 terms in the parentheses. All right, our last GCF one. So we got a 6, a 12, and a 3. What number goes into 6, 12, and 3? 3. They all have a C, but our lowest exponent on our C would be to the first. So we got 3C so far. Do they all have a D? Yep, lowest exponent on our D is the first. So again, I want you to take a minute. Divide each term by 3CD. And let's see what you get. So we should have 2c squared for our first term. 6 divided by 3 gives us 2. Subtract your exponents on your c. Your d cancels. Minus 4cd. And then plus 1. Because again, both your letters canceled. 3 divided by 3 is a 1. You have to have that 1 there. There was 3 terms when we started. There has to be 3 terms in our parentheses. All right. Last kind of factoring we're going to go over today is our dots factoring, difference of 2 perfect squares. The key thing there is that they have to be perfect squares. Now, hopefully with your numbers, you're familiar with them. We just finished our unit where we had to do a lot with our perfect squares. You had to be able to find your perfect squares. So hopefully they're still up there in your brain. When it comes to letters, any even exponent is a perfect square. So here they want us to write each of the following as a monomial squared. So 49 is the same as 7 squared. Because 49 is a perfect square. It's 7 times 7. So then 16x squared would be 4, because 16 is 4 times 4. For the x, it would just be x to the first power and then that squared. So 4x and then squared. What would it be for letter C? What gives us 64? What times what? 8. And then y squared, we would have y to the first in there. So an 8y squared. That's what gives us 64y squared. And then our last one would be 10y squared. So now they want us to be able to practice finding our perfect squares. So looking at example A, 9x squared, they want to know if that's a perfect square. Well, is the 9 a perfect square? Yep, 3 times 3. Is x squared a perfect square? Yep. So 9x squared is a perfect square because both parts are. But for B, we have just 4x. 4 we know is a perfect square, but x to the first is not a perfect square. It needs to be an even exponent. So how about 8x squared? No, 8's not a perfect square. The x squared is, but the 8 wasn't. And then how about 25? Yes. 25 is a perfect square. So what I want you to do right now is we're going to multiply these 3 out. We're going to have you take your time. Remember, you have to do your double distributive. So you're going to do x, and you're going to distribute through. So x times the x would give us an x squared. X times the 2 would give us a positive 2x. So now we have to distribute our negative 2. So negative 2 times x would give us negative 2x. Negative 2 times 2 would give us a negative 4, because negative times positive is negative. What happens to our x's right here in the middle? They're going to cancel each other out. Positive 2 minus 2 gives us a 0. Those ones cancel each other out. So our final answer here would be x squared minus 4, which that right there is a dots problem. It's 2 perfect squares. X squared is perfect, 4 is perfect, and there's a subtraction sign in the middle. So what I want you to do right now is go ahead and multiply through for your B and your C. I want you guys to try that on your own. Squared minus 25 for that last one. And again, these are all examples of dots problems because you've got 2 perfect squares with a subtraction sign in the middle. So now we're going to go from the answer up to the beginning part. So again, I wrote the steps on there, but it's easier to go through it than to actually read what all the steps are. So the first one, you have to be able to figure out, is it actually a dots problem? So remember, it has to be difference of 2 perfect squares. So do we have a difference of 2 perfect squares for letter A? Yes, we do. So we're going to set up 2 sets of parentheses. One of them is positive, one of them is negative. Does not matter which one is which. Your first parenthesis could be positive, second one negative, or you could flip it. So then you have to ask yourself, what multiplies to give us x squared? X times x. So we're going to put those in the first spot since x squared was in the first spot. And then what number times itself is 16? 4. There we go. X squared plus, or x plus 4, x minus 4. So B, do we have a dots problem with B? Yep. Those are perfect squares. So I'm going to set it up. 2 sets of parentheses. One of them positive, one of them negative. I put my negative one first this time just to switch it up. Now since our number is first, we have to have numbers first in our parentheses. So what times itself is 121? 11. If you don't know that, you could just use your calculator and take the square root of 121. You would get your 11. And then again, what multiplies to give us y squared? Y times y. So 11 minus y, and then 11 plus y. All right, C, do we have a dots problem? No. This one's plus. So this one's not factorable. It has to be a subtraction sign. That one does not have a subtraction sign, so it's not a dots problem. Let's try choice D. This one is subtraction. We have a dots problem again, so we'll set up our parentheses. 2 sets of parentheses, one's plus, one's minus. This time our exponent's not a 2 though, so all you have to do is divide that by 2. What multiplies to give us 4? So 2x squared will be our first terms there. And then what multiplies to give us 9? 3 times 3. So I want you to go ahead, try E and F. Let's see how you do. So let's see here. So for E, it should be x plus 3/4 and then x minus 3/4. Because if you look at each one, the 9 would be 3 times 3, and then the 16 would be the 4 times 4. You just make them a fraction, 3/4 and 3/4. Did anybody get the last one, do they think? Amelia? There we go. 3xy squared is your first terms. 7y is your second terms. All right, so once you